So thank you very much. Good morning. So I will speak about the comparison of genomic selection approaches in brown Swiss within intergenomics. This is a joint work with François Guillaume from the French Livestock Institute and Sébastien Fritz from the Union of Cooperative of AA Center. Sorry. So for concerning the data, 7,000 animals were genotyped on the 50K chip, and 6 countries were included in the analysis: the Swiss, the German population, the French, the Italian, the Slovenian, and the US population. Between 3 and 15 traits were available by country, and you have the distribution here for the production trait, the type trait, and the functional trait. So for this study, we only focus on 5 countries. We remove the Slovenian, where there is only 3 traits available, and we focus on the 10 common traits. So on this data, selection of useful animals for genomic selection was applied, and we consider useful animals as the one with genotype and index who belong to a family of at least 4 animals with genotype and index. So from the 7,000 animals, we move to 4,400 animals useful. And the pedigree file is also updated. Data were phased and inputted using Beagle software. A quality control was applied based on the minor allele frequency, the call rate, and the additive equilibrium. We calculate the regress proof from index, and animals of the training population with a weight of lower than 5 are removed from the analysis. So using all this information, the training population is composed by animals with the regress proof estimated or calculated in 2007, and according to the trait, between 400 and 3,400 animals were included in the training population. For the validation population, animals doesn't have any performance in 2007, and between 170 animals and 1,300 animals were included in this population. So thanks to these 2 populations, GBV for the years 2007 are estimated, and are compared to the de-regress proof in 2011. 4 methods were investigated: the genomic blob, the Bayesian lasso, the base CP, and the elastic net procedure, which is a penalized regression approach which combine ridge regression and lasso algorithm. The 3 last methods are especially done for the very large number to solve the problem of the large number of variables of SNP compared to the number of animals. And all these methods were compared to a pedigree-based blob. The 3 first methods, the genomic blob, Bayesian lasso, and base CP, we consider a polygenic component which vary between 10 and 90%. We test all the polygenic component part between 10 and 90%. And the results for the optimal polygenic component proportion are shown for each method and for each trait in the next slides. So here, there is a lot of numbers, so I will just focus on some of them. First, you can see that the pedigree-based blobs, so the 3rd column, give lowest value. So this is the correlation obtained between the observed regress proof and estimated one. And so the 3rd column, you can see that the pedigree-based blob is much lower than the genomic selection approaches. And the Bayesian lasso, base CP, and EN improve a lot this correlation and give approximately the same kind of results. And in red, you have the optimal correlation found. And for the same trait, it's the same method which gives the optimal result, whatever the country, except sometimes for the German population when we have some special results where BCP and EN are not required sometimes. So then this is for the production trait, and I will move very fast for the type trait and the functional trait, but you can see it's approximately the same kind of result each time. So if we look at the mean correlation per country, in Brunswick, the contribution of each country to the reference population is very different, and the mean correlation over the common traits are consequently different according to the country scale. And country with a high contribution will convert CD of abroad bulls with a higher accuracy. So it's what we observe here. The French population is the contribution of the French bulls is lower than the other country, and the mean correlation over the 10 traits is also the lowest one. And for the Swiss, it's the opposite. If we look at the mean correlation per method now, you can see on the first column this correlation over the 10 traits, and the pedigree-based blob is the lowest, gives the worst results. Then the G-blob improves a lot this correlation, but is also lower than the Bayesian lasso, BCP, and EN, which gives the best results. If we look at the absolute deviation to 1 of the slope of regression, we can also see that we improve a lot this variable, and the BCP and the Bayesian lasso give very good results in terms of slope of regression. And I just want to add a point with the 4 first method, so include a polygenic part in the model, which is not the case of the EN. It's maybe why we have a higher value of the slope of regression. If we now look at the mean of the polygenic component part over the 5 country scales, so we have this value for each trait, and you can see that for the G-blob, most of the time, polygenic component part of 10% is chosen. It gives the optimal result. For the Bayesian lasso, there's only one trait, which is a reorder 8, deviate from this value, and for the BCP, highest proportion of the polygenic component part are necessary to obtain the optimal correlation. If we look at the validation of the interval test, so we calculate the number of traits which validate the interval test per genomic selection approach, and that is to say the one where the slope of regression is included between 0.8 and 1.2. So the pedigree-based blob gives the worst result again, with approximately 6 traits over the 10 which validate the interval test. And for the other method, for the genomic selection method, this is the Bayesian lasso, the BCP, which gives the best result with, in average, 8 meters on 10, which validates the test. In conclusion, compared to pedigree-based blob, the genomic selection allows a gain in correlation between 6.5 and 21%. The Bayesian lasso, BCP, and EN give the best results with a gain in correlation near of 3% compared to a G-blob. And the slope of regression is closer to 1 with these 3 methods and are improved compared to a pedigree-based blob. More traits validate interval tests with Bayesian lasso, BCP, and EN also. For a same trait, the best correlation is often obtained using the same method, whatever the country scale. And the optimal polygenic part is relatively low, even if for the BCP requires a higher proportion than the 2 other methods. For the short-term perspective, we would like to apply a QTL detection and a genomic selection approaches based on QTL detection, that is to say the blob QTL. Thank you for your attention.